Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. So, now last time we got started with P1 trigonometry, and now we are on lecture 2 of trigonometry. And this time it's about a sketch. We'll be focusing on the sketch of y is equals to sine x, y equals to cosine x, y equals to tangent x. We'll be focusing on some basic transformation of graph. That transformation of graph could be related with a sketch or a stretch. We are drawing a sketch and we'll be doing a stretch. It will be related to translation and it can be related to reflection. And keep in mind, all these three things that I've mentioned related to transformation, that is part of functions, one of the toughest chapters of P1. We will study it over there also, but a little bit we will study also in this chapter and in this particular class. Now, let me just recap what we have done in the last time. We talked about right angle trigonometry. We talked about exact trig ratios. Just remember these values because I'll be using it. Take a screenshot if you have to. Sine of 30 is half. That's the same thing as cos of 60. Cos of 30 is root 3 over 2. That is sine of 60. Tangent of 30 is 1 over root 3. Tangent of 60 is root 3 over 1. And when we talk about 45 degrees, tangent of 45 is 1. Sine of 45, cos of 45, they are the same, 1 over root 2. And there were some rules over here, some rationalization that we did. Supplementary angles. This is not that much needed at this moment. But what we need is this thing. That in the first quadrant, all the trig ratios are positive. Quadrants are labeled, are measured when we are going anti-clockwise. So now first quadrant is 0 to 90. Second quadrant is 90 to 180 degrees. Third quadrant 180 to 360. 180 to 270. And fourth quadrant, that is 270 to 360. So just focus on this. First quadrant, all ratios are positive. Second quadrant, only sine. Third quadrant, only tan. Fourth quadrant, only cos. So now let me use this knowledge over here. Now what I can do is that I can plug in some values because we have to understand it from the very basic. That is, I can do some calculation for y is equals to sine of x. And I'm plugging in values between 0 and 360 degrees. So let me write 0, 30, 45, 60, 90. And then the next one, that is 120. And then 135. And then 180. And I missed one, which is which one? That is 150 degrees. So let me just push this over here. And this is 150 degrees. This is 180 degrees. And then I'm focusing on 210 degrees, 225 degrees, 240 degrees, 270 degrees. And then let me talk about 300 degrees, 315 degrees, and 330 degrees, and 360 degrees. So let me just take these values and let me copy it on the next page. There is some issue. Let me just go back over here. Okay, we will just write it rather than this creating a problem for us. So now when we talk about sine, sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of the next one, which is 270, is 0. Sine of 360. Sine of 270 is negative 1. And sine of 360 is 0. These are the 5 major values. Now let me focus on all those related to 30 degrees. So 30 is associated with 150, it's associated with 210, it's associated with 330 degrees. The value of sine is half. We talked about the relatives last time, but this is positive, this is positive, this is negative, this is negative related to the quadrants. When we talk about 45 degrees, so 45 is associated with 135. It's associated with 225. It's associated with 315. They all have the same basic angle, remember? So now this is 1 over root 2. 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 Acute positive, obtuse positive, reflex 1, reflex 2. They both are negative. And then we have 60 degrees. This is associated with 120. This is associated with 240. This is associated with 300. And let me pause for Azan. So I'll just pause the recording. So now let's go back. So now just focus on all the colored ones. Blue is associated with blue, 30 degree, first quadrant, 180 minus 30, 150, 180 plus 30, 210, 360 minus 30, 330. That is why they have the same trig ratio. And we know that sine is positive in first and second quadrant. Sine is negative in third and fourth quadrant. The same goes for 45 degrees and its relative. The same goes for 60 degrees and its relative. And let me write down the value of 60. This is root 3 over 2. This is root 3 over 2. This is negative root 3 over 2. This is negative root 3 over 2. That's how the table is filled. Now, what I can do is that I need to draw a graph out of this. That is what we are focusing on. So let me first focus on this, a graph going this way. We are starting with this thing. That is the y-axis. That is the x-axis. Let me just copy this thing. I'll be using it. And this is add element over here. Okay. So now the graph is something like this. So therefore, there is one portion like this. And then let me just extend it a bit. And then there is another portion like this. Now focus on this. This is 0. This is 180. This is 360. This is called one cycle. So this one wave is called one cycle, and it takes 360 degrees to complete its path. At 0, it's 0. It's at 180 is 0. At 360, it's 0. Just double check. So now 0 is 0. 180 is 0. 360 is 0. At 90, it's 1. At 270, it's negative 1. At 90 degrees, it's 1. At 270 degrees, it's negative 1. So this is negative 1 over here at 270 degrees. Now, the other values you don't need to draw. At 30, it is half. At 45 is 1 over root 2. At 60, it's root 3 over 2. At 90, it's 1. That is obvious thing. Now over here, this is the first quadrant. Between 0 and 90, that's the first quadrant, sine value is positive. Between 90 and 180, that's the second quadrant, again sine is positive. Over here, this is the third quadrant, sine is negative. Over here, it is the fourth quadrant, again sine is negative. And of course, why it is a curve and not a linear graph? Because between 0 and 30, there is a difference of half, but 30 and 60 again a difference of 30, but this difference is not half, it is less than half. So that is why it curves out. And these are the five major points that we are interested in. The first major point, second, third, fourth, and fifth. So these are the five major points. So 0, 90, 180, 270, 360, 0, 1, 0, negative 1, 0. These are the five major points that you need to show in the graph. So now just have a good look. And let me just double check one thing. Yes, the voice is all good, all open. And just acknowledge it on the group. That is sine graph. Is this all good, all clear? Okay, people, let's get started with this. Now let's talk about the graph of y is equals to cosine x. So now y is equals to cosine x. Again, we can apply the same principle, but I leave it up to you to fill it out. So that is 0. And then again, the same thing, 0, 30, 45, 60, 90. And then we have again the same series over here. That is 120, 135, 150, 180, and so on. And then over here, we have 210, 225, and then 240, 270. Then we have 300, 315, 330, and 360. So let me fill up the major values. That is this one. At 0, it's 1. At 90, it's 0. At 180, it's negative 1. At 270, it's 0. At 360, it's 1. That is the five major values. And then just focus on the common ones. So 30 is associated with 150, it's associated with 210, it's associated with 30 degrees. This value, this is cos of 30 is root 3 over 2. So this one will be the same, this one will be the same, this one will be the same, except cosine is positive in first and fourth quadrant. Cosine is negative in second and third quadrant. So you have to take care of the positive negative sign. Similarly, if I talk about these, that is 45, that is associated with 135, associated with 225, associated with 315. Now, this particular value, this is 1 over root 2. And then, of course, take care of all these things. Similarly, what is 60 degrees associated with? 60, cos of 60 is half, and 60 is associated with 120, with 240, with 300. So that is how you fill it up. Now, coming back to this, if I draw the graph of this thing, and let me grab this thing from here. And now, if I want to draw the graph of cosine, how will I draw it? So let me choose this thing. That is over here. No, not this thing that goes like this. Like this. Like this. So now at 0, it's 1. At 90 degrees, it's 0. At 180 degrees, it is negative 1. At 270 degrees, it's 0. At 360 degrees, it's again a positive 1. So these are the five major points that we label. This is just the origin. So now 0, 90, 180, 270, 360, and this is 1, 0, -1, 0, 1. These are the five major values. This is y is equals to cosine of x. And let me just write it over here. This is y is equals to sine x. Now, what is the meaning of this thing? One wave, one cycle. If you continue, the wave will repeat. If you continue, the wave will repeat, and we will talk about it in a short while. So sine is done, cosine is done. Let me also wrap up tangent over here. Now, tangent is kind of special. And tangent is special because of a reason. Again, the same values 0, 30, 45, and then 60, and then 90, and then 120, and then 135, 150, 180. And then we have 210, 225, 240, 270, 300, 315, 330, and 360. One other thing, yes, one other thing. That is, this is the first quadrant, cosine is positive between 0 and 90. Second quadrant, cosine is negative. Third quadrant, cosine is negative. Fourth quadrant, cosine is positive. So the reality can also be seen from the graphs. Be very, very clear about it. Now over here, the major points, tangent of 0 is 0. Tangent of 90 is undefined. Tangent of 180 is 0. Tangent of 270 is undefined. Tangent of 360 is 0. Now this undefined. Tangent of 90 is undefined. That's the same thing as tangent of 270. So we draw a vertical asymptote to show the undefined thing, which I'll soon show. Again, the values that are the most common, 30, 150, 210, 330, tangent of 30 is 1 over root 3. Again, 1 over root 3, 1 over root 3, 1 over root 3. First quadrant is positive, second quadrant is negative, third is positive, fourth is negative. Similarly, we can talk about 45 degrees, 135 degrees, 225 degrees, 315 degrees. Tangent of 45 is 1, 135 negative 1, 225 positive 1, 315 negative 1. And this one over here, that is the reddish one, 60, 120, 240, 300. They are linked. Tangent of 60 is root 3. 120 is root 3 with a negative sign, then root 3 with a positive sign, then root 3 with a negative sign. So now this is all done. Now let's draw the graph of this thing. So let me just change the color. And let me draw tangent, and I'll be needing slightly taller y-axis over here. So let me just draw this thing. Okay, now this is good. And this one is y-axis. That is the x-axis. Now, first of all, let me draw two dotted lines. First of all, I'll be drawing it like this. And let me just copy this. Okay. Now, the first thing first is that the first portion of the graph looks like this. And I'll just soon draw it dotted with this precision eraser. So that is showing the dotted line. That is the vertical asymptote. The first asymptote is at 90 degrees. Tangent of 0 is 0, 90 is undefined. So a guiding point could be 45 degrees, tangent of 45 is 1. So that's a good way of showing this value. And then between 90 and this thing, 180 degrees, let me draw another line, blue color, like this. And that is going like this. Okay. So now this is 180 degrees. That is the third major point. So 0, 0, 180, 0, 90 undefined. And yes, there is a special point of 45 degrees. Now, I can also label another special point between 90 and 180, that is 135 degrees. So at 135, this is negative 1. It's not drawn to scale, it's just a realistic diagram. Now, let me draw the remaining part of the graph that goes like this, and this goes like this. So now over here, let me label it. This is 270 degrees, again undefined, 360 degrees, 0. And now there are two cycles in 360 degrees. There is the blue cycle, and then there is the green cycle or the green wave. It's a broken wave. There are vertical asymptotes at 90 degrees, vertical asymptote at x is 90, at x is 270. That is on the right hand side of the graph. That is the first and foremost thing. So now sine is done, cosine is done, tangent is done. All three graphs are done and dusted. Now this thing is done. Let's move ahead. Now, the very first thing that I want to focus on is that extend the graphs. So now let me go over here and let me just use some eraser. Erase, no, not that much. Okay. And let me pull this thing in the middle. Okay. Now what I can do is that let me draw a small scale graph and let me just copy this thing. So now let me just draw this thing and let me draw a bigger line over here. Okay. No, this is good. Nope. Okay. So let me draw this. Okay. Now let me draw the graph of sin x. That is one cycle on the right hand side. And then let me draw on the left hand side because the same thing will continue like this, like this. So now let me just draw it. That is a little bit out. Okay. So now that is the graph. This is 0. This is 360. This is on the right hand side of the y-axis. This is 0. This is negative 360 on the left hand side. This is negative 180. This is positive 180. This value is at 90. It's 1. So this is 90. And then this is negative 1 at 270. Again over here. Again over here. So now I can see two waves. One wave, the red one, it's from 0 till 360 degrees. And the other wave, the green one, that is from negative 360 to 0. Got the idea? So it's a waveform. It depends on how much you want to limit it. So now if the examiner would ask, draw the graph of y is equals to sine x lies between negative 360 to positive 360. That is how much you will draw. Similarly, if I want to draw cosine using the same standard, so now let me choose the same color. And this time it's like this. That is one waveform. This is one. Not bad. Let me make it better. Okay, now this is better. And let me draw it on the other side also, like this. And let me push this to the left. Something like this, okay? So now let me label it again. This is y is equals to cosine x. This is 0, 90, 180, 270, 360, 5 major points. This is 0, negative 90, negative 180, negative 270, negative 360. And this last part is not that smooth. So let me draw it like this. Okay, so now again, these are two cycles. The first cycle is the red one, that is from 0 till 360. The other cycle is the green one, that is from minus 360 to 0. Got the idea? So this is y is equals to cos x, and x lies between negative 360 to positive 360. So now basically I haven't done any transformation except that I have just drawn some extended graphs. Now again, let me focus on this thing and let me draw the graph of tangent. So now let me first draw and then you decide from where till where I have drawn this. So now this is like this thing. Now this is like this. Something like this. Okay. Just ignore the curvature. It's not an art paper, it's a math paper. So now I have drawn a dotted line like this. Let me just draw it more accurately. This is more realistic, approximately. And let me just remove this. Let me first draw it. And let me do this correction on this also. Okay. So first of all, let me grab the red color, actually the green color. something like this. Let me choose the purple color. That's the purple. Okay, that's going like this. And then this pinkish color. Okay, so what do you see? You see tangent. First of all, that is true. Y is equals to tangent x. This is 0. This is 90. This is 180. This is 270. This is 360. This is negative 90, negative 180, negative 270. This is negative 360. How many cycles do you see? This is 1. This is 2. This is 3. I forgot to change the color. That is the third one. And then there is the fourth one. So I see 4 cycles. 0 till 360 degrees, there are 2 cycles. And negative 360 to 360, negative 360 to 0, there are 2 cycles. Got the idea? So there are 4 cycles over here. So now all the extended cycle that is done and dusted. So now extended graphs ranging from negative 360, negative 360 to positive. Where is the positive sign? Yes, there it is, positive 360. So is it all got all done and dusted? Just acknowledge it. And now I can start with the transformation. This is not yet transformation. This is just drawing extended graphs. Now what I'll do is that I take the example of sine and apply all my transformation to sine, and then I can extend it to cosine also. So now when we start with transformation, so the concept of transformation, there are 6 transformations, out of which we focus on the first 4 in trigonometry. The rest of them, we can try it out. We will, not we can, we will try it out in functions. So now, first of all, we can talk about reflection. Reflection in x-axis, reflection in y-axis. The second thing is translation. So we can do translation along y-axis, along x-axis, and then along y-axis. And the third thing, that is the stretch. So stretch could be along x-axis, along y-axis. So right now, I'll be focusing on this thing. 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 So there are 4 transformations that I'll focus in our trigonometry for right now. This will be done later in functions. This will be done later in functions. All good? So now when we talk about reflection, so first thing, reflection, that is the first one. And we will write this thing as y is equals to negative of fx. If there is a negative sign on the outside, it means reflection in x-axis. Positive will become negative, negative will become positive, 0 will remain as 0. That is the basic idea. So now if I draw the graph, let me choose the grid over here. And if I just shift this to the left, and let me draw the graph of sine x a little bit extended. So hold for a second. I forgot that thing. This is one portion, and then this is the other portion, like this. Now, when I want to reflect it, let me focus on the five major points: one, two, three, 4, and 5. These are the five major points. The red one, that is the graph of y is equals to sine x. And I'll be drawing the blue one, y is equals to negative sine x. Okay. Now, if I want to draw negative sine x, what I'll do is that this value is over here. This value goes up like this, approximately. And the graph is like this. Let me change the color of this thing. So let me make it green. Okay. So now if I want to draw this graph, I'll go like this. I'm drawing it dotted. Just have a feel for it. So now y is equals to negative sine x. That is y is equals to negative sine x. Positive became negative. Negative became positive. Zeros remains as zeros. Now, what I have done to sine x, you can also do it to cosine x. So that I leave for you. So draw y is equals to cosine x, draw y is equals to negative cosine x, and then you can see the reflection. Very simple. Red one, y is equals to sine x. That is the first transformation. Let me go to the other transformation. That other transformation is, let me talk about stretch. And over here, I'll be talking about the first stretch that is along y-axis. It can also be read as parallel to y-axis. This is of the form y is equals to k sine x, or y is equals to k fx. Fx could be sine, fx could be cos, fx could be tangent. So this k over here, we are taking k to be positive, and this is called the stretch factor, and the graph is transformed by this factor. For example, let me draw the graph of this thing. And again, let me just remove this thing. No need over here. Let me first draw the original graph in green color. A little bit bigger, like this. Let me draw this thing this way. That is the original graph. So this one, this is y is equals to sine x. Five major points: 1, 2, 3, 4, 5, 1, and negative 1. This is 360 degrees. This is 0. This is 0. This is 360 degrees. Now I want to draw in blue color, or let me just draw the red color. So now I want to draw y is equals to 2 sine x. So y equals to 2 sine x in red color. And now what will happen? This one will be marked as 2. This negative 1, let me just put a dot over here. The negative 1 will be marked as negative 2. And let me draw it like this. So something like this. Like this. No, that looks very weird. So let me just draw it dotted like this. Something like this. This is positive 2. This is positive 2. This is negative 2. And this one is y is equals to 2 sine x. So what has happened? It has got stretched. The y coordinate changes. For example, the point originally, which was 90° 1, is becoming 90° and 2. So the change has occurred where this 1 is becoming this 2. Why? Because there is a 2 written over here. So y coordinate gets multiplied by 2, which is the value of k here. All got all clear? For example, if it was y is equals to half sine x, so 1 would become half. So instead of increasing, it would be like this. So now this is all good, all clear. It's a good idea that let me draw this thing, copy, and let me paste it over here. And let me just erase this thing, everything over here. Okay, so just ignore the other red marks. Okay, even if I remove this, no big deal. Okay, so now let me draw in green color once again the original graph, something like this. And then another one like this. Okay, so that is the original graph. That is y is equals to sine x. Let me remove this thing from here. Let me remove this thing from here. And let me draw the graph of y is equals to half sine x. So now over here, this is half, this is half. The graph goes like this. Got the idea? So it is artwork that you have to create. This is y is equals to sine x, the original one. And this is y is equals to half sine x. So this is half, this is negative half. A point such as 90° 1 is becoming 90° and half. A point such as 270° 1 will become 270° and negative half. Got the idea? This is one point, that's the other point, that is 90, that is 270. And what do you observe? The y coordinate is multiplied by half, which is the value of this constant over here. So that is how this thing is done. Stretch along y-axis. So now I talked about reflection. I talked about stretch. Stretch is along or parallel to y-axis. So is this all got all clear? Now, let's talk about the third thing. That is this one, which is translation. So the third one is translation. And when we talk about translation, this is along y-axis or parallel to y-axis. Now let's say y is equals to sine x and y is equals to sine x plus 1. And then I'll draw the other one. Y is equals to sine x and y is equals to sine x minus 1. So what will be the difference? Let's have a look. So let me just draw this over here. And let me also paste it over here. No, not this thing. Okay. So the original one I'm drawing in red color, sine x. Actually, let me draw it smaller. That is sine x. That is also sine x. So the height of the graph depends on your creativity. Let me draw the 5 major points. 1, 2, 3, 4, 5, one cycle in 360. And then over here, I'm drawing sine x plus 1. So let me copy this thing. And it's over here. And it has been shifted up by 1 unit. Color, let me make it green like this. Let me copy this thing. And let me paste it upstairs with the color change like this. Okay, not bad. Okay. So now this green one, that is y is equals to sine x plus 1. This reddish one, that is y is equals to sine x. Look at the 5 major points. This point has been risen up till here, raised up by 1 unit, raised up by 1 unit, raised up by 1 unit, the y coordinate. And then 1 becomes a 2, and then -1 becomes a 0. So that is how the translation is taking place. That means a coordinate such as 90, comma 1 is becoming 90, comma 1 plus 1. The y coordinate has increased by 1. 270 degrees, comma -1 is becoming 270 degrees, comma -1 plus 1, which is 0. That is how this thing is drawn. Now over here, let me involve cosine over here. So now this is cosine x. Let me write over here cosine x minus 1. So by mistake, I have drawn this, but just let me remove this and let me draw the graph of cosine. So hold for a second. I might be needing slightly bigger y-axis. Nope, that's too thick. Okay, so now cosine, let me draw it slightly enlarged. This is one portion. Let me just copy this, place it over here, color change, and then let me draw the next one. Okay, that is the other portion, realistic. Change the color. And then the last portion. Copy and paste on this thing. Okay, now let's focus over here. So this is the red one, that is y is equals to cosine x. And then the green one, y is equals to cosine x minus 1. Now, in the previous example, 1 unit One, the difference between two lines is written as 1, but over here I've changed that. Now this is 1, this is -1, major point, major point, major point, major point, major point, and this is 360 degrees. This is 0 over here, and other points are there. Now we are transferring it 1 unit down. So let me take this thing up, and now it is transferred 1 unit down like this. Let me take this thing, attach to it, something like this. Let me take this thing, no, not this thing, let me remove it, and let us join forces like this. Got the idea? So now the 5 major points, the 1 has transferred to 0, 1 has transferred to 0, 0 has been transferred to -1, -1 has been transferred to -2. So that is how the graph of cosine x minus 1 is drawn. Now, let me also introduce over here tangent. And this time, let me again draw this thing. And let me draw 2 cycles of tangent. So the first cycle in red color, first one, approximately like this. The second one in green color, that is going like this. And now there are 2 cycles. Y is equals to tangent x. There is a cycle in red color. There is a cycle in green color. And let's say, let me mark some major points. That is over here. This is 1, 2, 90 degrees. This is 180. This is 270. This is 360. And I'm interested in y is equals to tangent x plus 1. Now it's going from infinity to negative infinity. But there is a major point over here that is 45 degrees. At 45 degrees, this is 1. So now what I can do is that, let me draw in blue color, something like this. And that's how the graph is drawn. It has been shifted up by 1 unit. Similarly, shifted up by 1 unit like this. Shifted up by 1 unit like this. Shifted up by 1 unit like this. So now the red one has been shifted up. This red one shifted up. This green one shifted to purple. This green one shifted to purple. So that is how we draw. Again, this is an example of the same thing. That is translation along y-axis. So now, so far, we have studied this. Now let's recap what we have studied. I'm not telling you the fourth transformation because that takes time. Now y is equals to sine x. Now the thing is, the maximum value of sine is 1. The minimum value of sine is -1. One cycle, one wave is completed in 360 degrees. Y is equals to cosine x. Maximum value is 1. Minimum value is -1. Again, one cycle is completed in 360 degrees. Y is equals to tangent x. Maximum is infinity. Minimum is negative infinity. And 2 cycles are made in 360 degrees, or we can say one cycle is completed in 180 degrees. There is something special about it. At 90 degrees, there is a vertical asymptote, and there is another vertical asymptote at 270 degrees. And of course, it could be 90, it could be 270, it could be -90, it could be -270, as we have seen in the extended graph. Yes, there is a special angle that should be labeled on the sketch. And what is that? Tangent of 45 is 1. Tangent of 135 is -1, because this will help us in the vertical translation thing. So now, is this all good, all clear? So let's stop over here. That is about what thing? Reflection is done, stretch is done, translation is done. So translation, and this is parallel to y-axis. So parallel to y-axis. Now in the next class, we'll be focusing a little bit more on the combination of transformation. So let me just mark it over here that this is lecture number 2 of this online batch. So take care, everyone.